Alright guys, welcome to our next installment of videos on trapezoids and kites. We're going to make this very fast, very simple for you. When we look at quadrilaterals, we can think about your quadrilateral hierarchy, right? We start with general quads, and then we have the three offshoots of the quadrilaterals. And so what we kind of think about is really we split the quadrilaterals really in terms of the number of parallel sides. So we think about this, we have parallelograms all the way over here, which even though typically it's always centered, but parallelograms, and they have two pairs of parallel sides. On the far side, we have no pairs of parallel sides. We call those kites. In the middle, we have trapezoids. So trapezoids are special quadrilaterals because they have one pair of parallel sides. So we ask yourself, okay, what makes something a trapezoid? It's exactly that. It is a quadrilateral that has one pair of parallel sides. So let's go ahead and get into Inspire. And so you can see here we have quadrilateral ABCD. And it is definitely a trapezoid where BC is parallel to AD. And so this is the BC and the AD are called the bases. And normally when we think about base, we think, okay, it's what it's sitting on. But in a trapezoid, the bases are the parallel sides. So that's something that's really important for you to remember, that no matter how the trapezoid is oriented, the bases are the pair of parallel sides. So that's really important for you to notice. So understanding that BC is parallel to AD, what can you then tell me about angle A? So angle A versus angle B. And let's go back into here. It's probably a little bit easier to see that into here. Let me see if we can actually get a shape. And do we have trapezoid? There we go. This is actually an isosceles trapezoid. We'll talk about that here in a minute. If these two lines are parallel, what can you tell me about these two angles? And what you should notice is that this is a very special type of angle pairs. So remember, when we talk about parallel lines and transversals, these two angles are called same side interior. And what you need to remember is that they equal 180 degrees. So that's actually kind of cool. Now, that's one of the things I want you to notice. Okay. Now, the other thing is something called a mid-segment. If you remember about mid-segments from triangles, you should recall that the mid-segment connects the midpoints of the two sides. So what I'm going to do is I'm going to construct my midpoints. And then I'm going to construct my segment. And a couple things I'm going to do. We know that BC and AD are parallel. So let's measure the slopes. So the slope of BC is 108. Okay. And basically you can see some fluctuations in here. And again, that's just because of rounding errors. But there we go. That's where what it should be. What you should notice then is that the slopes of these are basically zero. All three of these have a zero slope. And in fact, geez, I did not do a good job at constructing this. Basically, what I want you to notice is that the mid-segment is parallel to the two sides. So that's really important that you understand that the mid-segment is parallel to the two sides. Now, here's what's even cooler about this. We'll measure the length of BC and the length of AD. And you notice that's basically about 22.84. And what do you notice about the length of the mid-segment? The mid-segment is half the length of the bases. So that's two things you need to remember. The midsegment is parallel to the bases, and it's half the sum of the bases. So that's really important that you guys remember that the midsegment is half the sum of the bases. Okay. So now I want to talk to you about this special type of trapezoid that we have here, and we'll call this an isosceles trapezoid. And it kind of comes out being an isosceles triangle, where your base angles are equal at both the top, bottom and the top, and your legs are equal. Now, what's kind of cool about this is that if that's the case, then your diagonals will also be equal. So these are, there's a lot of information here to take in, and I want you to make sure you get all this down. That if it's an isosceles trapezoid, your legs are congruent, your bases are parallel, and your diagonals are congruent. And we can actually prove this using congruent triangles. So let's start off on this. If we look at this triangle right here, and you notice that we have a side and we have the full angle, and then we have the base. So here's our, we have our base here, and then we compare that to this triangle. We can show that those two triangles are congruent by side, angle, side. So those two triangles are congruent, which means their corresponding parts are congruent. Therefore, the two diagonals, this line and this line, must be equal by CP/CTC. So all that stuff that we learned about previous is still playing a big role here in a lot of our math that we see going on right now. Okay, so that's trapezoids in a nutshell. The next thing I want to talk about is a kite. You remember, kites are basically a quadrilateral with no parallel sides. But kites are actually kind of cool, because if we look at here, we have a kite. And a couple things I want you to notice about the kites. We'll go into measurements, length. Even though we don't have any parallel sides, we actually have two pairs of congruent sides. So in effect, you actually have two isosceles triangles that share the same base. That's really what a kite is. It's just two isosceles triangles. So what I'm just drawing here is one diagonal, and then I have another diagonal. Now, the longer diagonal, I shouldn't really say longer, but notice that which 2 points it is the two vertex angles of the isosceles triangles. That is actually an angle bisector. So if I measure the angle, notice it's 38.6. If I measure just the inside angle, it's 19.3. And so you can clearly see then that this long line here bisects these two angles at the top. Okay? It does not bisect these angles here. Okay, so that's really important. The other thing I want you to notice is that the diagonals are perpendicular in a kite. So that, again, is really important. Which means that you do actually have 4 right triangles, 2 of which are congruent, and another pair of congruent triangles. So those are some things I want you guys to think about when we talk about kites. And so hopefully you guys wrote all that down. I know I'm speaking really fast, but you always have the opportunity to go back and review the video, back it up, and write down some of those properties again. So hopefully you guys have your notes and you're ready for the quiz tomorrow morning. Have a good day.